Yes, you're welcome to our new video. Thank you for using QuestLift. Thank you for watching our videos. In this video, I want us to introduce yet a new topic of physical chemistry. And in this topic, we are going to be discussing electrochemistry. Now, in electrochemistry, we shall be studying the transfer of electrons from one chemical species to another, and then we shall also be looking at the relationship between the electron transfer that happens with the current that is generated. We are going to be seeing how chemical reactions occur and lead to generation of current. All we know that current is what we use and call electricity. So there are chemical reactions that take place, and then we can have electricity that can be used to do very many things. So we are going to study the genesis of electricity from chemical reactions. And in our study of electrochemistry, we shall look at different concepts that finally shall bring a whole understanding of how the chemical reactions involved can be or can give off energy that can be converted into electricity. Remember the conservation of energy, that it is neither created nor destroyed, but can be transformed from one form to another. So in our study in electrochemistry, we are going to look at electrons being transferred from one chemical species to another, and then in relation with the current generated when electrons are moving, and how this current generated can be used into electricity. So, what are some of the key components of this topic that we shall look at? In this topic, we shall look at what we call conductivity. We shall understand the meaning of conductivity. And in this conductivity part, different from physics, here we shall be looking at specifically what we call electrolytes. So conductivity of the electrolytes. And after that, in number 2, the other thing that we shall look at, we shall also have a view of what we call redox reactions. We shall know something to do with redox reactions. Reactions that involve both oxidation and reduction. It is these reactions of oxidation and reduction that will lead to transfer of electrons and generation of current. So we need to understand what do we mean by redox reactions. Also, we shall have a look at what we call electrode potentials. Electrode potentials. We shall understand what do we mean by electrode potentials. Then we shall also have a view on electrochemical cells. Number 4, we shall have what we call electrochemical and electrolytic cells. We shall have a view, and while looking at electrochemical cells, we shall have to understand how do we construct electrochemical cells. What are electrochemical cells? How are they different from electrolytic cells? These electrolytic cells are the ones that are used to carry out what we call electrolysis. These ones are the ones used to carry out what we call electrolysis. And then these electrochemical cells are the ones that we use in the construction of devices or things like batteries. And we shall be looking at their applications, very many applications of electrochemical cells. So in our journey of looking at electrochemistry, we shall go through these sub-topics. And for the start, we shall start by looking at conductivity. Conductivity of electrolytes. Now, in our discussion of what we mean by conductivity, we shall be using certain terms, and these terms that we shall be using, we need to look at a few of them. First of all, term number one that we shall need to know is the meaning of an electrolyte. This is going to be a common term in our discussion. What do we mean by an electrolyte? Or what are electrolytes? Now, a substance is going to be defined as an electrolyte if it can conduct electricity in solid state, if it can conduct electricity when in molten state or when dissolved in water, but cannot conduct electricity in a solid state. Meaning that electrolytes are substances which will conduct electricity when dissolved in water, that means when they are aqueous, or when in a molten state. And when electricity or current is passed through them, they normally decompose, they normally break down. So we shall be saying that an electrolyte is a substance that conducts electricity in aqueous or molten state and is decomposed by it. Decomposed meaning it does not remain the same at the end when current is passed through it or when electricity is passed through it. And this also means that electrolytes do not conduct electricity in a solid state. When they're in solid state, they will not. Those substances that conduct electricity in solid state are what we call the conductors. The conductors are covered in physics. Now in chemistry, we want to look at the electrolytes. Substances that conduct electricity when in aqueous state or in molten state, and at the end they are decomposed by it. So we shall be knowing how are they decomposed by it. The other term for decomposing is breakdown. So we shall be looking at what we call an electrolyte. Then we shall also be looking at the types of electrolytes, and we shall see things like a covalent electrolytes. There are electrolytes in nature that are covalent, especially when they are pure. And these electrolytes do not conduct electricity in their pure form because they are covalent. However, when dissolved in water, these electrolytes will undergo a process of ionization and dissociation. And when they do so, they will acquire ions. The process of ionization is an attainment of charge by atoms that are close to one another. And so, covalent electrolytes normally do not conduct electricity in pure form. But in aqueous state, they will conduct electricity. And when they conduct electricity, It is because they have undergone the process of ionization and dissociation. So we shall be saying that these are covalent compounds. These are covalent compounds that conduct electricity when dissolved in water, conduct electricity when dissolved in water, but do not conduct in their pure form. For example, things like hydrochloric acid. This substance, in the pure form HCl, is a non-conductor. But when dissolved in water, it will conduct electricity because it will undergo the process of ionization and dissociation. So we shall say that this is because they undergo ionization and dissociation when dissolved in water to form ions, that can move and conduct electricity. So, in electrolytes, what conducts electricity are called the ions. That's why when solid state and ions are very close to one another, not free to move, they will never conduct electricity. Now, this is one type of an electrolyte. Then, the other type that we can look at are called ionic electrolytes. Now, ionic electrolytes in a solid state do not conduct electricity because of a very strong electrostatic force of attraction between the ions. So when we talk about the so-called ionic electrolytes, majorly consist of salts. Now, these salts here, when in a solid state, they will not conduct electricity. Reason, the ions are strongly attracted to one another. And because they are strongly attracted to one another, the ions are not free. There is a very strong ionic bond. And because of that strong ionic bond, these ions are not free to move. However, when this compound is heated and it undergoes the process of melting and we acquire a molten state of the compound, then the ions are free because some ionic bonds have been broken. And once the ions are free, then they can conduct electricity because of the ability of the ions to move. Now, if we do not melt and we don't heat them to melt, then we can dissolve them in water because most of these ionic compounds are soluble in water. So once you dissolve them in water again, you break the strong ionic bonds and then the ions are free to move. So we shall be saying that ionic electrolytes, these mainly consist of solid ionic compounds, that conduct electricity when molten or in aqueous state. In aqueous state. In a solid state, they do not conduct electricity because the ions are strongly attracted to each other by electrostatic forces of attraction. Electrostatic forces of attraction are forces of attraction between opposite charges. However, when heated to melt or dissolved in water, the ions become free to move and conduct electricity. So, those are called ionic electrolytes. Then, under these two, the covalent and the ionic, we could have strong and weak electrolytes. Now, a strong electrolyte must be one that undergoes complete dissociation once dissolved in water to release a very high concentration of the ions. So whenever we talk about strong electrolytes, then we are talking about those electrolytes capable of undergoing complete dissociation. So we shall be saying strong electrolytes, that these are electrolytes that undergo complete ionization and dissociation. They undergo complete ionization and dissociation. For example, hydrochloric acid is a strong acid. When dissolved in water, undergoes both complete ionization and dissociation. If we looked at a salts undergo complete dissociation, and if they undergo complete dissociation, the salts, then they are going to have a lot of ions in solution, and so they will be regarded to be strong electrolytes. So strong electrolytes, we look at those electrolytes that undergo complete ionization and dissociation into free ions. Then, if we are looking at the weak electrolytes, these undergo partial ionization and dissociation, and therefore in a solution they will release a low concentration of free ions. So they undergo complete and partial ionization and dissociation to release a low concentration of iron is. So in this case, we would look at weak acids, for example. Weak acids. Weak acids are regarded to be weak electrolytes because when dissolved in water, they undergo partial ionization. Now, in the next lesson, we shall be looking at more other detailed terms connected to the conductivity of an electrolyte. Don't miss, we are simply introducing. Thank you.